Now, by plotting all of the isotopes that we have with their number of neutrons to the number of protons in the nucleus, what we have is this kind of curve of stability. But there are other isotopes which lie off this line, and it tends to be the heavy ones, they give out alpha particles, and as they do so, that gets them closer to the line. We also get beta minus given out, and also beta plus. And by giving out these, basically by giving out radiation, they become closer to the line. And if I'd like to look at this one here in a bit more detail. So when you have beta plus being emitted, what we get is inside the nucleus, we have a proton that ends up turning into a neutron. And as it does so, it also releases a beta plus particle. Now, if we think about this in terms of charge, we've got something which has a charge of +1, 0, and +1, so charge is conserved. Baryon number, well, that's got a baryon number of 1, and that's got a baryon number of 1, and that's 0, so that's all good. When we consider lepton number, we've got 0, 0, and this one here has got a lepton number of -1, because it's an antiparticle. So there has to be another lepton which is emitted, which in this case is an electron neutrino. But there's more and more way in which a proton can end up turning into a neutron, and that's by what we call K capture or electron capture. So this proton captures an electron, it turns into a neutron, and in order to conserve lepton number, because we've got a lepton number of +1 here, we also then have a lepton number of +1 over here. So an electron is captured by the nucleus of an element, and this tends to be the elements down here which basically are proton heavy, and they don't have enough neutrons. So the proton number goes down by 1 and the neutron number goes up by 1. And in doing so, it also releases an electron neutrino and often some other kind of form of energy in the form of radiation. Now, a great example of that, and there are many here, is carbon-11. Now, carbon-11 has 6 protons. I'm using the yellow Lego to be my proton, so it's got 1, 2, 3, 4, 5, 6, which means it must be carbon. In this case, it also has 1, 2, 3, 4, 5 of the red ones, and so there are 11 nucleons in total. There are 5 neutrons and 6 protons, so it's kind of proton heavy. And what happens is that basically it captures one of the electrons from the inner shell, and the inner shell is also known as the K shell, which is also why it's called K capture. And effectively one of these things here, basically as it goes near to the nucleus, it gets captured by a proton. The proton turns into a neutron, and what we then have is a different element. So if we think about that, carbon-11 is basically this. We have an electron which is grabbed by that, and then this means that we only now have 5 protons left. If we look at our periodic table, we find that this is boron. There are still 11 nucleons there. We've still got the same amount, and also an electron neutrino is given off. And what happens then is at some time, one of these electrons in the outer shell is going to move back down, it might give out a packet of energy as it does so, and then we again have our full inner shell of 2, and then we have our outer shell of 3. So that's K capture, and it's just another way that an element can change from one form to another to become more stable and give out some kind of particles. Thank you.